Hi guys, we're back with another interesting video. It's time to explore something new. Before that, thank you guys for your valuable subscriptions. If you're new to the channel, subscribe to us and press the bell icon to stay tuned with us. Now let's get into today's video. Guys, what is quantum computers? What is wormhole? Did the Google quantum computer create an artificial wormhole? Confusing? Yes, it sounds a bit complicated. Let's see what it is. First of all, what is Google quantum computer? Simply, it is a rapidly evolving technology that uses quantum theory to solve some of the most difficult and complex problems that conventional computers suffer to face. Data is processed using quantum bits or qubits as opposed to conventional bits in quantum computing, ones and zeros. Quantum computers are much faster than classical computers for some types of problems because qubits have the special ability to exist in multiple states simultaneously. This allows quantum computers to perform many calculations in parallel. Quantum cryptography, which is thought to be unbreakable, is the most well-known application of quantum computing. As the first quantum computer to carry out a calculation that is beyond the scope of conventional computers, Google developed a quantum computer called Google Sycamore, which was unveiled in 2019. Sycamore, a 53-qubit quantum processor, completed a calculation in 200 seconds that would have required 10,000 years on a conventional supercomputer. This demonstration illustrated the capability of quantum computing to resolve complex issues in a small portion of time required by conventional computers. In order to create useful quantum applications that can be used in sectors like finance, chemistry, and healthcare, Google continues to research and develop quantum computing technologies. And next, what is a wormhole? We have heard this word in a lot of movies, books, and fictions. Science fiction frequently uses the idea of wormholes to describe ways to travel through time and space. However, they have not yet been seen or demonstrated to exist. They are merely hypothetical at this time. The concept of a wormhole is related to the theory of general relativity and the notion of space-time in physics, but whether they exist and whether it's possible to travel through them are still unanswered questions that are the subject of ongoing research. Wormhole was started in 1935. Albert Einstein and Nathan Rosen proposed the Einstein-Rosen bridges, also referred to as wormholes, as solutions to the general relativity equations in 1935. According to one theory, these objects are space-time shortcuts that might be used to connect distant cosmological regions. They are still a subject of debate and investigation in theoretical physics and astrophysics because their existence has not been proven. Although wormholes are predicted by some general relativity solutions, research into their stability and potential for use as a faster-than-light travel method continues to this day. An imagined shortcut through space is a wormhole, a hypothetical structure in space-time. It is a tunnel-like structure that might link two different points in space-time, allowing information or matter to move between them, having to physically travel the distance between them. The same concept applies in computing too. The term wormhole is occasionally used in computing to refer to a specific inter-process communication (IPC) mechanism. In computing, a wormhole is a direct connection between two computer processes or points in a network that enables data to be transferred instantly without having to go through any intermediary nodes. High-performance computing and parallel processing frequently use wormholes to increase the effectiveness of communication between processes and decrease the latency associated with conventional communication methods. They can also be used to connect various systems, such as various computer networks, and enable the swift and secure transfer of data between them. A wormhole in computing is a direct and effective channel of communication between two points that can be used to send data or information securely and quickly. Is it possible to create an artificial wormhole? It is possible. Similar to the idea of a wormhole in physics, it is possible to create direct connections between two points in a network or a system that allow for effective and direct communication. Communication between components is an important thing in computing. It decides the overall performance of the system. If the communication is slow, then the performance will be restricted. By avoiding intermediary nodes and reducing the latency involved with conventional communication techniques, artificial wormholes can establish direct communication between components. This could lead to quicker and more effective communication between the parts, which could enhance the system's overall performance and scalability. In high-performance computing and parallel processing, where large amounts of data must be transferred between numerous processing nodes, artificial wormholes are frequently used. They also can be used to connect various systems, such as various computer networks, and enable the swift and secure transfer of data between them. As a result, the need for efficient and effective communication between various components in a network or a system leads to the need for artificial wormholes in computing. By establishing direct connections between components and lowering latency, they can enhance the performance and scalability of large or complex systems. This idea is evolving in different ways day by day in the technology world. Then, did the Google quantum computer create an artificial wormhole? Yes. A device called Sycamore, powered by Google's quantum computer, has successfully recreated a wormhole using quantum mechanics. Maria Spiropoulou from the California Institute of Technology is the leader of the team that created this artificial wormhole. They were able to simulate a wormhole and inject quantum information into it to observe the results. Quantum information, qubits, were fed into the wormhole. This investigation serves as evidence for the holographic principle. Harvard professor Daniel Jaffer has created a wormhole teleportation protocol which provides instructions to create a wormhole using a quantum computer step by step. Then Dr. Maria Spiropoulou and team collaborated with Google in testing this protocol. SICK version was used for this research. At the beginning, it was the goal of the researchers to build a holographic wormhole using only 7 qubits as operations, but it was a lengthy and a complex process. It took them few years to achieve it in a clever way. The team trained the system to eliminate as many network connections as it could, while still maintaining a crucial wormhole signature by mapping the particle interactions of the SICK model onto the connections between neurons of neural net. The method reduced the hundreds of 4-way interactions to just 5. This was a midway success boost for them. Then using this, their team then began programming the qubits in Sycamore. 14 matter particles are encoded by 7 qubits. The left and right SICK systems have 7 each. Every particle on the left and right are intertwined. A particle from the left SICK model is then swapped for an 8th qubit that is in the same probabilistic combination of states 0 and 1. This tangling enables even information spread. Then in tandem with a pulse of negative energy moving through the wormhole, all the qubits begin to rotate rapidly. It encouraged right-hand SICK model where the information unspread. At this point, the team waited for a peak in the data that indicated a distinction between 2 cases. If they noticed a peak, it indicates that qubits can teleport by qubit rotations that are dual to negative energy pulses. Qubits cannot pass through rotations in the opposite direction, which are dual pulses of regular positive energy. With this idea, they almost gradually improved around 2 years towards the success. One fine day, they noticed the peak they were expecting. As a bonus, the researchers discovered a second wormhole dynamics signature, a delicate pattern in the way information spread and unspread among the qubits known as size winding, despite the wormhole's skeletal simplicity. As we always say, technology is unstoppable. Nobody have ever imagined that we could create a wormhole inside a lab quantum computer, while Einstein came up with a wormhole concept. This is not the end. There are still many more inventions to surprise us in future. As All says, quantum is the most complex study ever. There are still rooms for inventions related to wormholes, interior of wormholes, and etc. using new technologies. So we still don't know if this is the top or if many more models with more advanced software and processors will emerge in the future. Nevertheless, it's a fascinating journey into the mysterious depths of information in quantum mechanics. Whatever the miracle of tech gifts us, we are always ready to keep you updated with exciting and evolving information. Until meeting you all with another interesting topic, we're signing off for the day. Don't forget to subscribe and press the bell icon for more informative videos. Like, share and subscribe to our channel. Thank you guys. Meet you soon with another video.